Hello, ladies and gentlemen, and welcome back. In this video, we're going to be starting Part B of our 2013 Grade 7 Gauss paper with question number 11. Now, since we're starting a new part to the paper, I thought I'd extend just a nice little invitation. If you haven't already gotten a copy of the contest and tried the questions, you can get a copy for free by clicking the very first link down in the description below. Try question 11, 12, try everything that's left on the paper. If you're interested, remember practice is the best way to sort of increase your abilities. Anyway, the length of each edge of a cube is 1 centimeter. The surface area of the whole cube in centimeters is... Okay, so we got a nice little cube. They're saying the length of each edge, so we might be able to quickly imagine this little cube. And it's 1 centimeter, 1 centimeter, and 1 centimeter. I mean, all the others are 1 centimeters, but you really just need to know the length, the width, and the depth, or height, whatever you want to call it. And we want to know the surface area. Okay, so let's work out the surface area sort of on our own, and then I'm going to show you there's a nice little formula for this for cubes. Okay, so if we imagine the whole cube and we sort of visualize that we can see through it, okay, what have we got? Well, over here on this side, and this side, we've got 2 blue squares here, and these squares are both 1 by 1. You know, they're both the height times the width, let's say. Okay, so we've got 2 of these 1 by 1 squares, and the area of them is just going to be 1 times 1 or 1. We've got 2 of them. And if we look at the top and the bottom, we get some of these green squares that have the length and width of our rectangle in common. They're both still going to be 1 by 1 squares. And so each of them has an area of 1 times 1, or 1 centimeter squared. And there's 2 of them. We get 2 of those. And then, of course, the front and the back are also going to give me 2 1 by 1 squares. And each of them has an area of 1, so that's a total of 1. And we get 2 plus 2 plus 2, a total of 6 for the surface area. Now, you might say, well, hold on, there were 6 squares, why didn't you just do 6 times 1? You can do that for cubes, I'll get into that in a moment. But more generally, if you've got a rectangular prism, you don't always have the same lengths everywhere. But for a rectangular prism, if you've got length, width, and height here, you're going to get 2 rectangles that are both the height and the width, which give a surface area of h plus h times w. You'll get 2 with length and width, and 2 with length and height, just pairing them up. Then this here gives me the formula for not just a cube, but the surface area of any rectangular prism, just in terms of its length, width, and its height. Okay? And if it's specifically a cube, if specifically h and w and l are all the same value, and we have a side length of, say, s, it's s's everywhere, then, yeah, there are 6 squares, and each of the squares is an s by s square. And so the general formula for a cube's surface area is 6s squared, where s is the side length. And so 6 times 1 squared does give us our original answer of 6. But I thought, if you haven't seen the cube surface area formula, there it is. If you're not familiar with the general rectangular prism surface area formula, here it is over here. Okay? And of course, you don't need to know any of those formulas, because the way we did it first, we just said, all right, we've got some squares. What are their areas? Add it all up. So you can do this with formulas or without. And if you didn't know these formulas, now maybe you do. And we can say, all right, the total surface area for this cube is going to be E6. All right, and there we go. That's question number 11. Up next, question number 12. I will see you there.